Welcome students. In the previous class we discussed the exercise problems of your textbook, okay, from simple machine, and today we actually discuss the rest of the questions that actually question number E and F. Okay, so today at first we discuss about the question number E1. Okay, what is your question? Actually, the question is using a suitable example, describe how a machine acts as a force multiplier. Okay, so we already know machine is generally used in different types. Okay, and we also know why machine is used because machine is used changing the magnitude of applied force and also the changing the direction of applied force. Now the question is actually describe how a machine acts as a force multiplier. Okay, so we take an example that is actually bottle opener. Okay, we generally take bottle opener. In this case, actually machine is used or a machine acts as a force multiplier. Okay, so because it is very difficult to open a sealed metal cap of a cold drink bottle, okay, with our own hand. Okay, it is very difficult to open a sealed metal cap of a cold sealed drink bottle with our own hand. However, a bottle opener actually it multiplies. Bottle opener multiplies multiplies the applied force. Okay, multiplies the applied force or the effort applied or the effort applied on it. Okay, hence actually much less effort is required. Hence much less effort is required to open the cap. To open the cap. Okay, so such type of machines are called force multiplier machines. Okay, so in generally for this question we use an example that is bottle opener. In this case, bottle opener multiplies the applied force or the effort applied on it. Hence, much less effort is required to open the cap actually. Okay, now we move our next question, that is actually question number 2. Okay, so what is the question? Draw diagrams to show the position of load, effort and fulcrum in class 2 and 3 lever and explain how their mechanical advantage are different. Okay, so actually you have to draw block diagram. Okay, that is why you at first we take class 2 lever. Okay, we already discussed what is the position of load and effort and fulcrum for class 2 lever. In this case, actually, we draw a lever. In this case, one end which is actually fulcrum. This is your fulcrum, and one end we applied actually effort. This is your effort, and in the middle actually load is placed. Okay, this is your load. So here actually L is equal to, we can say, load, and E is equal to effort, and F is fulcrum. Okay, and in this case we already know what is the distance of load arm, that is actually LF. LF is equal to load arm and EF is equal to effort arm. Okay, so here from this figure we can say that actually effort arm is greater than load arm. Okay, that means we can say EF is greater than LF, and for this type of lever we know mechanical advantage is equal to effort arm divided by load arm. Okay, that is why always mechanical advantage of second class lever, class 2 lever is greater than 1. And if we draw class 3 lever actually, then we take this type of block diagram. In this case actually one end is fulcrum F, and in this case load is placed in one end. This is your load, and effort is applied in the in between actually for fulcrum and load. So here actually effort arm, that is effort arm, that is actually EF is less than load arm, that is LF. So here mechanical advantage is equal to effort arm divided by load arm, that is always less than 1. Okay, you take one example for actually third class. This is your class 3 lever. Okay, this is class 3 lever. In this case you take an example. This is example you take actually fishing rod human forearm. You take one example human forearm, and for class 2 lever actually, for class 2 lever you take an example that is actually bottle opener. Okay, this is bottle opener. Now we move to our next question, that is actually question number 3. This is what is an inclined plane and list the uses of an inclined plane. Okay, so from your book you can define what is inclined plane. Actually you have to write definition. Okay, definition of inclined plane. Definition of inclined plane. Actually inclined plane is a rigid sloping surface over which heavy loads can be raised or lowered to a certain height. Okay, so it is actually rigid. It is a rigid sloping surface. Okay, sloping surface over which heavy loads can be raised or lowered to a certain height. To a certain height or depth. Okay, and the next part of this question is list the uses of inclined plane. Actually, a list of uses. Okay, so actually we use inclined plane in different cases. Okay, So at first you have write first one, you have write list of uses. Okay. So first one you have write actually a heavy box need to if a heavy box needs to be loaded needs to be loaded. Okay, needs to be loaded on a lorry, then we can use glen plane. Okay, the next one you use actually in this case we when we want to carry or sorry when we want to move a heavy load to a certain height. Okay, or on hills, staircase, etc. Staircases, etc. Okay, now we move to our next question. Question number 4. Okay, so we move to our next question, that is question number 4. In this question, actually question is what is a screw? Describe its advantage over a nail. Actually, what is screw? Oh, you can write the definition of screw, that is in your book. Okay, the definition of screw is it is a cylindrical rod marked with winding spiral edge called thread. Okay, so it is a cylindrical rod. It is a cylindrical rod marked with winding spiral edge, okay, called thread. This is the definition of screw. And what is its advantage over a nail? Actually, it is used actually for screw. It grips the wood more firmly than a nail. Okay, because it has a thread. Okay, in generally the tip of the screw is narrow, sharp and pointed. The head has a narrow slit. Okay, so in generally if we use a screw, then the screw grips the wood more firmly than a nail. Okay, because of its thread. So advantage, because of its thread, a screw a screw grips the wood more firmly than a nail. Okay. Now we move to our next question. That is the next question is actually this is question number 5. Describe a pulley. Okay. So at first you have to write down what is the definition of pulley. Actually, a pulley is a wheel. Okay. it is a wheel, okay, or a circular disc, or it is a wheel or a circular disc, circular disc that can rotate freely, that can rotate freely about a fixed point, about a fixed point. And the next part of this question is differentiate between a single fixed pulley and single movable pulley. Okay, so we already discussed single fixed single fixed pulley, axis of rotation is fixed. Axis of rotation is fixed, and for single movable pulley actually, and for single movable pulley, axis of rotation is not fixed. Rotation is not fixed. Okay. Now we move to our next question. Question number 6. Okay. So in this question, mention any 3 ways by which we can take care of machine. Okay. We actually write the uh, questions, answer of the question from your book. Okay. So machine should be kept in a clean environment. Okay. First actually machine should be machine should be kept in a clean environment. In a clean environment. Next one is actually machine should be kept covered too. Should be kept covered. Machine should be kept covered. Okay. Should be kept covered to prevent the collection of dust. To prevent the collection of dust. And the next is 3. Machines made of iron should be protected from rust by coating them with paint. Okay, so machines made of iron made of iron should be protected from rust by coating them with paint. By coating them with paint. Okay, this is the actually answers of the questions E. Actually in details question, this is the long question actually. Now we move to our next part, that is actually solve the following numerical problems. Okay, so first question F1, that is actually if a fulcrum of a crowbar a of total length 150 centimeter is at a distance of 25 centimeter from the load, what is the mechanical advantage of a crowbar? Okay, that means here actually what is the total length of crowbar? Actually total length of crowbar is equal to 150 centimeter, and the load is at a distance 25 centimeter. from fulcrum. Okay, that means load distance. Load distance is equal to, from the question, 25 centimeter. Now actually how we find out what is the effort distance? Okay, so in this question actually load distance is given and also total distance is also given. So what is actually the effort distance? Okay, from this case actually total length is 150 centimeter and load distance is 25 centimeter from fulcrum. That means we can say actually for this particular question the effort distance is equal to, what we can say, you already know actually it is actually crowbar. Okay, so you know actually which type of lever is crowbar? Which type of lever is crowbar? In generally crowbar is class 1 lever. Okay, so in this case you have huge effort distance. What is effort distance? For this case crowbar is a class 1 lever, that means fulcrum is in between actually load and effort. That means here effort distance is equal to 150 minus 25, that means 125 centimeter. Now we have to find out mechanical advantage. So mechanical advantage is equal to, we know what is the definition of mechanical advantage. Mechanical advantage equal to effort arm by load arm. Okay, so effort distance here 125 by load distance centimeter divided by load distance, this is also 25 centimeter, that means 5. Mechanical advantage of crowbar is 5. Okay, similarly we move to our next problem. Actually the next problem is the handle of a nutcracker is 18 centimeter long and a nut is placed 2 centimeter from the hinge. If a force 36 kg is placed on the nut, it will crack. Okay, so calculate the force which has to be applied at the end of handle to crack the nut. Okay, so in this question actually, so you have to know which type of lever is a nutcracker. Okay, we take question number 2. Okay, so for nutcracker the length is actually length total length of nutcracker is 18 centimeter. Okay, and a nut is placed 2 centimeter from its hinge. Here nut is actually load, so here from hinge, that means load arm, or we can say load distance is equal to 2 centimeter. And here actually what is the effort? Similarly you have to know what actually nutcracker means or which type of levers. Actually nutcrackers is class 2 lever. Okay, so in this case one end is fulcrum and one end is applied effort. So here, so we can say for this case actually in this question force of 36 kg is placed on the nut. Okay, that means here actually load is equal to load is equal to 36 kg. Okay, is placed on the nut, it will crack. Okay, now calculate the force applied at the handle of the. Okay, so we have to know what is effort. Okay, so at first we have find out mechanical advantage. Actually we know mechanical advantage equal to effort arm divided by load arm. Okay, load arm. Okay, so here actually a foot arm is equal to total length of, actually because it is a second class lever, that means a foot is placed at one end and also fulcrum is placed in one end. That means total length of the nutcracker is the distance of a foot arm. That is why we can put 18 centimeter divided by load arm, that is 2 centimeter. So we can say mechanical advantage of nutcracker is 9. Now question is what is the value of effort? Okay, so we know mechanical advantage is equal to, also we know mechanical advantage is equal to load upon effort. Okay, so we have to find out actually load is 36, effort. So we have to find out effort is equal to load upon mechanical advantage. So load is equal to 36 kgf divided by mechanical advantage, that is 9. That means the answer is actually 4 kgf. Okay. Now we move to our next question. Okay. So in this question here also a crowbar of length 100 cm is used to lift a load of 50 Newton. The fulcrum is at distance 20 cm from the load. Okay, calculate the mechanical advantage of crowbar and the effort applied at other end. So this is actually similar type of problem. Okay, similar as question number 2. Okay, and you solve it. Okay, in the next, actually this is the end of today's class. In the next class we discuss the previous chapter. Actually this is the chapter number 4, that is actually force. Okay, so we discuss actually some previous knowledge about force. Okay, as yeah, force is in your pre-annual syllabus. Okay, that is why we in the next class we discuss about force. Okay.